So hopefully that was ample time for everyone to complete the warm-up. I'm glad that we've been able to establish this routine. You all know to come in, you have 6 minutes to complete the warm-up. If you don't have that time, or if for whatever reason you're not able to access the warm-up during the designated time, obviously you still have time to complete the warm-up. I don't want to punish you all for having technical issues or technical difficulties. So you have until the end of the unit to complete all of your warm-ups and exit tickets. Obviously, I do encourage you to complete them in their designated time so that you don't end up getting backed up and having a whole lot of work to do the day before the exam. But that feature or that policy is there just in case you all experience some technical difficulties trying to access the warm-up. Now we'll go ahead and jump into the lesson. We've also established a policy of taking strong, accurate, efficient, and effective notes. So to practice good organizational skills, we do encourage you to be sure to write down what you're seeing on the screen, starting with this first slide about the title of the lesson, the date of today's lesson, and the fact that it is Unit 7, Day 4. So the title of today's lesson is Multiple Alleles. That's that hard word. It's difficult to pronounce a little bit. The date is October 29th, 2020, and it is Unit 7, Day 4. As you all write down that basic information, I will read the objective and the essential question. So by the end of today, biologists will be able to predict offspring ratios of traits that are determined by multiple alleles by completing practice problems. The essential question: how can we determine the potential blood types of children based on their parents' blood types? So today we're going to introduce these concepts of multiple alleles, meaning the traits that are determined not by 2 alleles, as we've discussed over the last 2 days, but actually by 3 or more. Okay, but before we do that, this class, we did not complete the notes yesterday, so we need to go back a bit. We introduced practice problems to you all, some that we did together and some that I asked you all to do on your own time. Those are all available to you on Canvas per usual, but we never got to this portion about codominance. So if you could go back to your notes from yesterday, I'm sorry if I kind of messed up your rhythm here. We have one more concept to introduce, and that is the concept of codominance. So on Tuesday, we talked about complete dominance. Yesterday, we talked about incomplete dominance, and today we will introduce codominance. Codominance is when both alleles are equally dominant. There is not one allele that is recessive. And again, we always want to focus on the heterozygous genotype. That will allow us to describe this type of inheritance. So what happens with the heterozygous genotype in the case of codominance is that both phenotypic traits are equally shown. This might look like spots. This might look like stripes. This might look like multicolored coats. We see this cat here, it's got some parts of its coat that are black, other parts that are blonde, other parts that are white. This is the result of codominance. And we see that the traits, the phenotypic traits, are shown equally. So we want to focus on the heterozygous genotype. Now, the steps to solving these codominance Punnett squares are exactly the same. We're not doing anything differently here, but there is an important difference that I want to call your attention to. I'll give you about 5 more seconds to write down the definition of codominance. Okay. So at the beginning of yesterday's lesson, I introduced this chart to you all. I asked you to write down this chart in your notes. We have on the left side of the chart, in the furthest most left column, we have the type of inheritance. Again, Tuesday we talked about complete dominance. Yesterday we talked about incomplete dominance. And today we're introducing a third type. And that third type is codominance. The phenotype that is expressed by the heterozygous genotype is not blended. We don't end up with a mixture of the two. We end up with both being expressed. And the other important difference that we need to talk about involves how we write the genotype when we're talking about codominance. So with complete dominance, we used a capital letter and a lowercase letter. With incomplete dominance, we used 2 capital letters, but we also used an apostrophe. We called that prime. That's what we talked about yesterday. Today, we're talking about codominance, which uses 2 different capital letters. So they might be B, for example, we might have BW to represent black and white. All right, so now we're using capital letters, but they are different capital letters. So please go ahead and make that addition to the last row of the chart that I asked you to draw yesterday. And then we'll jump into some of the practice problems. Okay. So here's a practice problem that says if black chickens are codominant to white chickens, show a cross between a black chicken and a black and white chicken. So always when we are involving these crosses or these Punnett squares, our first step, as we know, is to make a key. Our key tells us what our genotypes are and what the corresponding phenotypes are for each of those genotypes. So we've got the genotype, which describes the genetic makeup. It uses the alleles, the letters. We've got the genotype BB. That corresponds to a black phenotype. Phenotype describes the physical characteristic. We also have the genotype WW. That's also homozygous because they're the same allele. And that genotype describes a white phenotype. Lastly, we have the heterozygous genotype. This is the one that we focus on. This heterozygous genotype is BW. It's hetero because we've got two different alleles. We've got a B and we've got a W. And because this is codominance, this leads to a spotted phenotype. Spotted because we've got, as we can see with the chicken in the top right, we've got both white and black present in the chicken's coat. Okay. So now we need to show a cross between a black chicken and a black and white chicken, one that's spotted. So let's go ahead and get ready to do that. So I had my key on the last screen. I'll go ahead and rewrite it just for convenience. So it's here for us. BB is the genotype for a black chicken. BW is the genotype for a spotted chicken. And W, and again, I really encourage you all to write these practice problems with me. That way you can refer back to them as you do your asynchronous assignments and study for your exams. There's my key. What should I do next? I know many of you, this is second nature for you at this point. What comes next? Yes, now we need to actually do our cross or determine the genotype, as Jessica says, but how do I do that? What should I draw next?
Box.
Yes, I got to draw my actual box. My Punnett square. Okay, so there's my Punnett square. Maybe I should go ahead and label it at this point too. 1, 2, 3. Now you don't have to number your boxes. It just kind of helps you keep track. Okay. What now? Keep in mind, we are mixing, we're crossing a black chicken and a white chicken, a black chicken and a spotted chicken. So what's next? Come on, folks. We've been doing this for 2 days now. You all should know. Okay, set up the cross. So what should I do when I set up the cross? What should I write? I want some very specific directions here. Tell me like you're teaching me. Okay, I apologize. I lost my internet connection. Technical difficulties don't discriminate. But that's a great opportunity for me to remind some of you, maybe some of you who are newer to the class or who haven't done it yet, to join our remind code. So text at RUDDSBIO2 to 81010, or download the Remind app and enter the join code RUDDSBIO. Oh, I'm sorry. It should be BIO3. So ignore the first message.
Mr. Wood,
Yes.
did you get that last answer? The
What last answer?
BB and the W?
Okay, hold on. Give me 1 second. Okay. So what are you saying, Brian? What should I do?
Oh, I wanted to see if I could get that right.
What do you want me to do, though? Can you see my screen?
Yeah, I can see your screen. I was wondering if you already answered it or not.
Oh, no, I haven't answered it yet.
Okay.
I still have one more step before I can actually do the cross. I need to write the other parent in. So it said we are crossing a black chicken with a spotted chicken.
Yeah.
So where should I write the spotted chicken's genotype?
At the 1 and the 3, so put the B in near on the left. So
Yes,
B
on
and
the
W.
left. Good. Good. Now we can do the cross. So what would go in box 1?
BB.
BB. Good. What about box 2?
BB.
Also BB. What about box 3?
BW.
And box 4?
BW.
Excellent. Okay. So what is the percentage of black offspring? What percentage of my 4 offspring are black?
50.
Excellent. What about spotted?
50.
Excellent. And what percentage of them are white?
0.
0. Good. Excellent job. Okay. So let's make sure we got that correct. We put our black parent on top. The spotted parent went on the left. Then we did our cross, and that's exactly what Brian just gave us. And then he gave us the phenotypic ratios as well. We had a ratio of 2 to 2 to 0. We expressed it in terms of percentages. And so the percent chance of white offspring is 0. So excellent job, Brian. Let's see if we can do this one too. So we've got a red flower that is codominant to white flowers. If a red flower mated with a white flower, what are the chances their offspring will be spotted? So again, we've got codominance taking place here. So what's our first step? Always. What is always our first step?
To our box.
Yes. Well, not, okay, well, I could do that first, but typically we like to do something before that. And Jessica, you're always good with telling me what comes first.
Figure out what we have to write on the outside.
Yes, what were you getting ready to say, Fanique?
Make a key.
Yes, we've got to make our key. Good. Okay. So I always make a key first, guys. That's super important because otherwise you run the risk of just kind of getting lost in way information. you're being presented. All right. So in this key, I've got a red flower. I also had, they said that there's a spotted, where we're looking to find out how many spotted flowers there are. And there's also a white flower. So how should I write these genotypes?
RR,
Okay, excellent. RR,
RW,
good,
and then WW.
excellent. Okay. Now we're being asked to mate a red flower with a white flower. So what should I do?
Put RR on the top and WW on the left.
Good. So I'm just gonna put my WW on the left and my RR on the top. I
got the answer.
Okay, good. Hold on. I want to make sure that we label the boxes just so you all can really see what's going on here. You don't need to do this if you kind of are moving through this pretty easily. But Brian, what goes in box 1?
RW.
What about box 2?
RW.
What about box 3?
RW.
And box 4?
RW.
Good. They all end up with the exact same RW, 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 RW. So what's the percentage of red flowers, Brian?
0.
0. What about spotted flowers?
100.
Excellent. All of our flowers, all of our offspring are going to be spotted. And what about white?
0.
Good. All right. So good. Finally, someone is picking up and helping me out here. Should be moving through this pretty easily. So I'll come back to this tab. We'll check our work. What are the chances their offspring will be spotted? We made our key. We set up our cross with the red flower and a white flower. All of the offspring end up having the genotype RW, which means that they are red and white. They're spotted. So the chances should be 100%. Okay, I'm going to skip over this last one for now so that we can make sure we cover the what we actually need to cover today. But there are plenty of practice problems presented to you in yesterday's module, so Unit 7, Day 3. So I do encourage you all to do those practice problems. If you'd like me to look over them and check them, I can definitely do that. This is also a good opportunity. I'm just coming up with all good opportunities. For you all, again, I want to mention this one more time. You might be sick of hearing me say it, but there are opportunities for you all to sign up for some one-on-one tutoring. So far, no one has used that opportunity in over a month. And that's not good because it was not even a month ago that we had midterms. So next time, as we're preparing for exams, it's a good idea for you all to get some questions answered. All right. I just sent the link to the chat where you can go to calendly.com and sign up for an appointment with me. All right, so quick review because we just talked about it, but the 3 types of inheritance: complete dominance, incomplete dominance, and codominance. There are some differences between all 3. Hopefully you all wrote down that chart that I showed you already. But we really want to focus on the heterozygous genotype, the heterozygous phenotype. So in complete dominance, when I have a heterozygous genotype, meaning I've got 1 dominant allele and 1 recessive allele, the phenotype of that is going to be the dominant trait. Because the dominant allele will mask the recessive allele. In incomplete dominance, if I have a heterozygous genotype, so I have, let's say, R and R prime, the resulting trait is going to be a blend of both the dominant allele and the recessive allele. And then in codominance, if I have a heterozygous phenotype, let's say I've got R and B, then my trait is going to show each of those alleles equally. All right, today we're introducing multiple alleles. There are some traits that require more than 2 alleles to determine. Now, of course, every human being only gets 1 copy from each parent. So you still only have 2 alleles, but there are more than 2 possible alleles. Maybe there are 3 or 4 or 5 or so on. The most classic example of this is blood type, where we have 3 possible alleles, A, B, and O. So 3 or more possible alleles for an individual trait. Human blood types have 3 alleles, A, B, and O. We consider A and B to be codominant. Now, you might be wondering, why is blood type important? Blood type is important because it determines who you can give blood to or donate blood to, as well as who you can receive blood from. People who have the blood type AB can receive blood from anyone. They can get blood from people with blood type A, people with blood type B, people with blood type O, and of course, people with blood type AB. But unfortunately, they are not good donors. People with blood type O can give blood to anyone, but they can only receive blood from people with blood type O. Okay, so A and B are codominant, and then O is considered recessive. So this is a good chart to write down. Please do copy this table down in your notes. We've got 4 phenotypes for blood. You could have blood type A, blood type B, blood type AB, or blood type O. Blood types A and B have 2 possible genotypes that can result in their phenotype. So, for example, I could be genotype AA and have the blood type A, or I could be genotype AO and have the blood type A. That's because O is recessive. Same thing with blood type B. There are 2 genotypes that could result in a blood type B phenotype. One person could be genotype BB and be blood type B, And another person could be genotype BO and also have the blood type B, because the O is recessive. Now, blood types AB and O can only result from a singular genotype. In order to be the blood type AB, then a person would have to have the genotype AB. In order to have the blood type O, then a person would have to have the genotype OO. It's a homozygous recessive genotype. You'll also notice on the right column, of this chart, that there's another way of denoting these genotypes. Sometimes you'll see them written with I's, the letter I. So we use a capital I for our codominant alleles, A and B. And we use a lowercase I for our recessive allele, O. Of course, using a capital I could be both A and B, so we also have to write which one it is. We have to write a superscript, meaning a small letter written up top, to indicate if it's a capital I for A or a capital I for B. Now, I think most of you will find it easier to just use A's and B's and O's rather than using the I version, but it's also a matter of preference. All right, I'll leave this up for about 10 more seconds so that you all can finish copying it down. All right. So we got a practice problem. Stacy has blood type A and her husband has blood type B. Note that we see the genotypes there as well. Stacy is heterozygous. She's got an A and she also has an O. She's AO. Her husband is homozygous B, so he has two Bs. Blood type AB is known as the universal recipient. So they wish to have a child with type AB. Is it possible? Okay. So again, what's the first thing we need to do? It's the first thing we should always do. Thank you, Jessica. Excellent. So we first need to make a key. Here's our key. Now I'm going to do something a little different for our key. Oops. So we have Stacy, who's the mom. Stacy had the blood type IAI. Another way to write that is simply AO. Stacy's husband has the blood type B, and his is homozygous. So he's got IB, IB. But another way to write that is simply using B's. They want to know, is it possible for their child to have the blood type AB? So we need to do a cross. So what should I do next? Now that I've made my key, what should I do next to complete the cross? Excellent. Thank you, Jessica, and thank you, Makaran. We need to make our Punnett square, which you all are referring to as a box, which is fine. Okay, what should I do now? I want you all to direct me as though I have no idea what I'm doing. Okay,
The
we're
AO goes
gonna.
on top.
What'd you say, Brian?
The AO goes on top.
Good, and I see Jessica, you said that as well. So I'll put the AO on top,
And BB goes on left.
and BB goes on the left. Okay, so what goes in box 1?
AB.
What goes in box 2?
OB.
Okay, I'm gonna write BO, but it's okay to write it either way. What about box 3?
AB.
And then what about box 4?
BO.
Excellent. Okay. So our original question was, is it possible for them to have a child with the AB blood type? Well, not only is it possible, but what are the chances that they have a child with an AB blood type?
50%.
Exactly. It's a 50% chance. Good. So let's come back to the slides. Oh, I wasn't even sharing. Oh, no, I was. Okay, come back to the slides. Let's check and make sure that we got the right answer. AO and BB. We put the parents on the outside of the box. Then we make the box. We do our cross. We end up with AB, BO, AB, BO, just like Brian told us. So it is obviously possible. Good job. Okay. Another practice problem. A baby with blood type AB is born to a mother with type A blood. A man, whose name is James, claims to be the father. James has type O blood. Could James be the father? Okay, so we're going to do a little bit of science and scientific investigation here to figure out if James has got some wishful thinking. He wants to be the dad, but he's not, or he wants to be the dad and he is. It'll be a good day for him. So let's figure this out. Again, what's our first step? We should be ready to give me this answer now.
Your key.
Thank you. You need to make a key. And Brian, I want to just go ahead and appreciate you for not being on mute. I mean, yeah, for actually saying your answers out loud. Just makes it a little bit easier on me. So I appreciate that. Okay, what should we put in our key?
The blood types.
Okay, good. So the mother has type A blood. So what is her genotype?
Can you ask that again?
Yeah, so we know that the mom has type A blood. So what is her genotype in that case? Her phenotype is type A, but what's her genotype?
I'm gonna let somebody else answer this one.
What's the question?
The question is, if we know that the mom's phenotype is type A blood, then what is her genotype? I see Nick has given us the answer. Thank you. We know that she could have two potential blood types in this case. That makes it a little trickier. She could either be AA, she could be homozygous, or she could be AO, which is heterozygous. Both of those would give her the blood type A. So we're gonna have to try multiple things here. We know that James has type O blood. So what is his genotype? Oh, thanks, Jessica. So the only genotype that can lead to type O blood is OO. That's the only one. What should I do next? I need to make my actual square. My box. Thank you, Jessica. Okay, now the thing is, we don't know what mom's exact genotype is. It could be one of two things. It could be AA or it could be AO. So what we need to do is make two of these Punnett squares. I need to make two because mom's genotype is unknown to us. It could be A or AO. Now we know James. We know James is OO. So I'm just going to put him out there. Our goal is to see if we can get a baby that has type AB, right? James wants to know if he's the father. We know that the baby has type AB blood, so we need to figure out if any of these could be type AB blood. All right. So let's start over here in this one. What goes in box 1?
AO.
I should have AO. What about box 2?
AO.
What about box 3?
AO.
And box 4?
AO.
Also AO. Good. So if we're just talking about if mom's genotype is AA Is it possible for James to be the father of an AB baby?
No.
No, it's not possible because we don't see any AB in the offspring in the Punnett square. Okay, what about box 1 of this Punnett square?
AO.
AO. What about box 2?
OO.
Oh, good. What about box 3?
AO.
Excellent. And box 4?
OO.
So what about in this Punnett square? Is it possible for James to be the father of an AB baby?
Yes.
It
No.
is?
No.
No, it's not possible. Because still, we do not see. Oops. We still do not see an AB baby anywhere in the offspring. We still do not see any AB genotypes. But we know the baby is AB. So James simply can't be the father. Whoever the father is, he must be blood type B. Let's just check and make sure that we did that correctly. Made our key. There are the possible genotypes. So we need to have, we needed to make 2 different Punnett squares. The first one, we gave mom the genotype AO. And again, she didn't have any AB babies in that case, not with James. Now we're going to change mom's blood type to her same blood type. We're not changing her blood type, but we're changing her genotype to AA. James is the same. This changes the outcome a little bit. All of their babies would have blood type A. But again, we know that the baby has blood type AB. That's what it says in the first sentence of the question. So it's just not possible that James is the father. All right, one more. This one's a little pop culture reference for you guys as well. The question reads, Future is claiming that he is the father of Culture, Cardi B's daughter. Offset says that it is not possible. We know that Offset is, actually Culture's father, or he's at least Cardi B's husband. Cardi B is blood type AO and blood type B. Culture is type O. Is it possible that Future is the father? Okay, so we've got a lot of different stuff going on here. We know Cardi's blood type is AO. That's her genotype. Future's blood type is B. We don't really know much more beyond that. And we know Culture's blood type is O. All right, so again, first thing we need to do, make our key. Cardi B is AO. Culture is type O. So what is her genotype? What's Culture's genotype if she's type O blood?
OO.
OO. Thank you, Brian. And then Future, we're told, has a blood type of B. So what are his potential genotypes?
BP
BB.
or BO.
Excellent. Thank you, Jessica. Okay, so again, we're kind of running into this problem, not a problem, but this complication. Future has 2 different genotypes. So we need to have 2 Punnett squares to determine if he is actually the father or could be the father. Okay. So let's put Cardi B on top. Oops. So we'll put AO on the top of both Punnett squares. But we know that Future's blood types could be both BB and BO. So let's start with this Punnett square over here. What goes in box 1?
AB.
A, B. What about box 2?
BO.
Good, B, O. What about box 3?
AB.
And box 4?
BO.
Good. So if Future's blood type is BB, is it possible for him to have an O child?
No.
Okay.
Already, can I answer? Oh, never mind. I'll wait.
I'm glad you can see it already, Brian. Okay. Let's go ahead and quickly knock this one out. So this Punnett square over here, what goes in box 1?
AB.
What about box 2?
BO.
Box 3?
AO.
And box 4?
OO.
Ah, so is it possible for him to have an O baby if he's blood type BO?
Yes.
Yes,
Yeah.
it is possible. Now, the interesting thing here that you all maybe can see is that if a person with AO blood type has a baby with a person with BO blood type, their baby could potentially be any of the 4 blood types. They could be AB, they could be B, like AB, they could be B, they could be A, or they could be O. So that's kind of interesting. But in this case, yes, we learned that it is possible. Good job. All right. So the next step in order for us to determine if Future is actually the father, I'm sorry, I wasn't showing, but this shows exactly what we just did. Yes, it is possible. Now, this is kind of a throwback to our 5th unit when we talked about genetics and we did DNA identification, or DNA fingerprinting. Actually, I think that was the 6th unit. But our next step to actually figure it out is to do a paternity test to figure out who the father is. So we've got the mother, who is Cardi B, on the left side with the purple DNA. We've got the child, who is Culture, in the middle. She's got a little bit of DNA from Cardi B and some red DNA that came from whoever the father is. We're told that male 1 is Offset and male 2 is Future. Can you all tell who the father more than likely is between these two?
Yes.
Who is it?
Male 1,
It's male 1. And how can you tell, Brian?
because his lines match up better than male 2.
Excellent. So offset then would be the father. We can see that the fragments of DNA from male 1 match up much more closely with the child. These two fragments are the exact same. These two fragments are the exact same. And these two fragments are the exact same as well. Male 2 has maybe 1 or 2 fragments in common with the baby. Maybe this fragment here, you might say maybe this fragment right here, but that's about it. So male 1 is much more likely to be the father of the child, and male 1 is offset. Good. Okay. So if you finish those Punnett square problems that were on Canvas from yesterday, I will give you extra credit for completing those. But in the meantime, don't worry about the exit ticket today because we didn't actually cover the information that's in it. You'll just have to do the exit. You'll have to do today's exit ticket tomorrow. And then there is an assignment today. There is an asynchronous assignment. I know we only have 6 minutes left. But it's called Punnett Square Practice. So if you need any help, I will be here on mute. We only have about 5 minutes left, but good job to Jessica, McKyron, Joseph. I think I heard Jaden a couple times, and definitely Brian.
You heard me too at the end. You heard me too.
I didn't hear you, Kyrie.
Yes, I was talking when Brian was talking.
Oh, okay. Okay, folks, it is now 1:22. I'm sorry, I lost track of time a little bit. But you all are good to go, and I will talk to you all tomorrow, Friday, to end the week.